Am I audible to all of you guys? Okay, cool. So let me share my screen. Is my screen is up to all of you guys? Okay, great. So let's start with the session, guys. Let me remind you what we have done in yesterday's session. So yesterday, we have started, discussing with neural networks, right? So we have discussed how our brain performs, right? And what is this dendrites, nucleus, axon, and synapse. Then we saw a typical neural network architecture like this one. And from this architecture, we understood that what is the concept of input layer, output layer, and hidden layers? What are these nodes are? What kind of a processing these nodes perform, right? And then we saw why we are calling this kind of a network as a feed forward neural network or sequential neural network, right? Okay. And then we have discussed like some introduction regarding the activation function. So the role of activation function is basically when it comes to the processing of a particular neuron or node. So the first part is the adder function, and the second one is the activation function. And we have also saw that there are a lot of activation functions are available, but we have to select which activation function we want to use for our neural network architecture. Okay. So these are the, a couple of activation functions like sigmoid, nh, relu, max out, leaky relu, elu, right? And you can use any one of the activation function based upon your data set. And then we also saw that it's up to you that in your neural network architecture, how many number of hidden layers you want to use. You can use 2 or 3 hidden layers. You can increase the number of hidden layers like 4, 5, or 6, 8, 9, something like that. And then you can also decide for each and every layer, how many number of nodes will be there, right? So all of these things a user can define based upon the problem statement, right? Now, one thing is very obvious. If you're using lot of hidden layers in your neural network architecture, then this architecture will become very much complex. So that will take lot of time to do the computations, right? So this is something we saw or we understood from the previous session. Okay. So up to this point, guys, any doubt or any queries, anyone, or we are good to go? Any questions, anyone? Okay, great. So let's begin with today's session, guys. So today, guys, we are going to deep dive into this neural network architecture, and I will show you how you can build your neural network architecture using Python, right, and deep learning libraries. So let me just give you a top view of how the things are arranged in deep learning or AI. So we are talking these things with respect to the deep learning. Okay. So guys, in the deep learning, we have a different kinds of a neural network architecture for different tasks, right? So out of that, we have a something called as a artificial neural networks. In short, we are calling this as a ANN, artificial neural network, right? Let me write it here. It's a artificial neural network, right? So this kind of a architecture we use for regression and classification related tasks. Regression and classification related tasks or classification models or regression models, we use ANN kind of a neural network architecture, which is a artificial neural network architecture. Then we have a something called as a CNN, which stands for the convolutional neural network. Convolutional neural network. And this kind of a neural network mainly works for image data or video data. So if you want to process or do, model building based upon some images or videos, so probably we use convolutional neural network, right? For images or video analysis, we use convolutional neural network, where the input is images, and based upon the problem statement, we do the analysis. Then here comes something called as a RNN, which is the recurrent neural network. R stands for the recurrent. Recurrent neural network. So this kind of a neural network, guys, we use for multiple purpose. Like we use this kind of a neural network for time series forecasting. We also use this kind of a neural network for text data analysis. So if you are using the RNN kind of a neural network for text data or time series forecasting, these are the application we are calling sequential data analysis. Sequential data analysis, right? So these are the example of sequential data analysis. And we do this kind of a sequential data analysis with the help of the RNN, which is a recurrent neural network. Then we have some advanced version of RNN, or you can say some modification is being done with the RNN due to some drawbacks. So we have two more versions of RNN. So one is known as the LSTM, which is again, it is useful for time series forecasting or text data analysis, both of the cases, and we call it as a sequential data analysis application. And then we have another architecture of the neural network, which is the advanced version of RNN, that is known as a GRU. GRU stands for the gated recurrent unit. LSTM stands for long short term memory, right? So in that way, we have these kind of a neural network architectures. Now, apart from these specific neural network architecture, we have some other applications of deep learning or AI. And for that, we have some advanced architectures like we have something called as a GANs, generative adversarial network. So guys, if you recall the first session of like introduction to generative AI, There I explained one of the application or tool present under this generative AI is GANs, Generative Adversarial Network, which are very much popular when if you want to generate the images. So if you want to generate some images which are similar to your input images, so in that case, this kind of a neural network architecture is very much useful, right? And then we have a couple of other architectures like variational autoencoders, VAE in short form. We have something called as a sequence to sequence model. We have something called as a transformers with attention model. Transformers with attention mechanism. Right? So guys, all of these advanced architectures are only built over this either RNN, LSTM or GRU, right? So ultimately they are using these kind of architectures only, right? So in this way, we have like these kind of neural network architectures. And obviously, if I especially talk about CNN, which is a convolutional neural network, we have a couple of advanced version of the CNN also. Let me just name all of these, modification or advanced version. So there is something called as a RCNN, which is some advanced form of CNN. There is something called as a fast CNN. And there is one more advanced version of CNN, which is called as a faster CNN. So just giving you an idea how things are arranged under the deep learning part, right? So this is the way we have things are arranged under the neural network or the deep learning. Can you expand LSTM? Okay, guys, LSTM stands for long short term memory. Long short term memory. GRE stands for gated recurrent unit. Right. So in that way, we have things are arranged. Is that clear, guys? And guys, whatever architecture we saw for the neural network, that is something artificial neural network architecture, whatever we saw, right? So whatever we have discussed, input layer, output layer, hidden layers. So that is the artificial neural network architecture. And that is the, you can say, basic architecture what we have. All other neural networks, whether it is a CNN, RNN, LSTM, GRU, or whatever you name it, this kind of a neural networks utilizes this ANN kind of a architecture with some modification only. So there also you will get input layer, output layer, and hidden layers. Along with that, probably some other layers or some kind of a modification. Right? Cool. Great. So let me remove this part. So I hope you guys are clear where we stands. So this is what we have understood, and we are now going to deep dive into this neural network architecture. Once we cover this ANN part, then we will jump towards the RNN part, right? We will see recurrent neural network and how it is useful in case of a text data analysis or time series forecasting, any one of the application, which is the sequential data analysis tool. And then probably we'll also see, basic understanding of this LSTM, and then we'll move towards the sequence to sequence model. And if time permits, I will also discuss transformers with attention mechanisms. Okay, so this is the like how we progress. Anyways, so let me discuss few more details regarding this neural network architecture. Okay, guys. So this is the architecture what we have. And in this architecture, guys, this is the input layer. Now, this is the layer where we provide the input to this architecture. Whatever input data you have, that input data is being fed into this input layer only. And as I explained you yesterday also, the nodes of the input layer, they do not do any kind of a processing, right? So the processing will be done by all the nodes except the input layer nodes. So these nodes will only contain the input data. Now, this input data will get passed to the layer 1, hidden layer 2, hidden layer 3, and they will process the information and they will carry forward. Now, if you guys recall how our brain performs with respect to the neuron, so there we have something called as a synapse. Synapse is the weightage given to each and every input connection, right? So just like the synapse, here also, for each and every connection, like these connections, these connections, these connections, these connections. So for each and every connection, there is some weights assigned to them. So generally, like most of the cases, whatever weights we assign, that value of the weight lies between 0 to 1 only. So let's say for this particular connection, the weight value is 0.02. Let's say for this connection, the weight value is 0.5. Let's say for this connection, the weight value is 0.09, something like that. So like this, for each and every input connection, we have some weights assigned. Now, how these weights are being assigned and how it will generate the output, right? So guys, initially, when we design this network, we will assign the weights randomly, some random number in between 0 to 1, right? So before executing this architecture or before executing this data, we will assign some random weight to all of these connections, right? Now, based upon this weight value, each and every node will perform the processing, and the processing will be same. First one is the adder function and then activation function. So with this random value of the weight, in the first iteration, they will do the calculation and they will generate the output. Now, this neural network architecture, it will calculate the error after each and every execution. After each and every iteration or execution, it will calculate the error. And to minimize this error, what this neural network will do, it will optimize this random value of weights. Whatever weights we have assigned in random manner, so it will try to optimize these values to minimize the error based upon whatever output value is being generated. Now, this particular part, what is the part? To reduce the error by minimizing the or optimizing the weight values. That is being done by something called as a optimization method. Or optimization technique, right? So optimization method or optimization technique, what this technique will do, it will try to minimize the error. And how it will minimize? Just by tuning this value of the weights for each and every connection, and it will try to get the optimum value of the weight. For that, the error will be minimum. Okay. So in that way, it will execute this neural network architecture multiple times. So it is not only one time execution. At the backend, it is being executed, let's say 100 times, 150 number of times, or let's say 500 times. So these many number of times at the backend, this network architecture will get executed. And for each and every time execution, this optimizer will try to adjust the value of these weights so that the error will be minimum, right? This is one thing. Now, most commonly used optimization technique is gradient descent. So guys, gradient descent is one of the most commonly used optimization technique in neural networks, right? There are a lot of other optimization techniques are there, but let's consider this particular optimization technique because it's a most commonly used optimization technique. We have some advanced form of gradient descent and some other modified form. Anyways, so this is one thing. Second thing is, guys, if you see here in this particular neural network architecture, in between any two layers, like input layer and layer one, in between layer one, layer two, layer three, output layer two, layer three, you can see each and every possible connection is available, right? So if I talk about in between layer two and layer three, so in between layer two and layer three, for layer two, we have these two nodes. For layer three, we have three nodes. So what are all the possible connections between these two layers? Like this node is being connected to this node, and this node. And this node is also connected to this node, and this node. That means in between any two layers, we have all the possible connections available. You can take the layer in between layer 1 and layer 2, input layer to layer 1, layer 3 to output layer. So in between any two consecutive layers, all the possible connections are being present. So if that is the case, this kind of a neural network is called as a dense neural network. Dense neural network, where we have all the connections available in between any of the two layers. Okay. Now there is one issue with this dense neural network. The issue is if we are using a dense kind of a neural network, so there is one particular issue which this kind of a neural network will go through. That is something called as a problem of overfitting. Now, what is this problem of overfitting? So this problem of overfitting is nothing but if you're using the dense kind of a neural network, so when you are building this particular neural network, that means when you are training this model, at that time, this kind of a neural network will perform very well. But when you are applying this model, this kind of a neural network over some test data or some live data, these neural network will get failed. So this problem is called as a problem of overfitting. That means while building this model, your model is performing very well. But when you are testing this model, your model will get failed. So this kind of an issue is called as a overfitting. And this is very common issue if you are using the dense neural network. Right? Then what's the solution? So solution is, let's not use all of these connections. Let's drop like certain number of connections in between any two layers, right? Let's suppose I will drop, let's suppose a couple of connections between input layer and layer one. Let's say these three connections. I will drop these two connections between layer one and layer two. Between layer three and layer output layer, let's say I will drop these four connections. So if you're doing this kind of a mechanism, then probably your network will not face, or this neural network will not face problem of overfitting. Now, this kind of a solution you can implement with something called as a dropout layer. Dropout layer. So there is something called as a dropout layer. What this dropout layer will do? It will drop certain number of connections randomly between any of the two layers. So it is up to you. Like you can decide like in between which layers you want to drop the connections. So you can implement this dropout layer between input layer and layer 1. You can also apply this dropout layer between layer 1 and layer 2, between layer 2, layer 3, between layer 3, layer 4. And based upon that, it will drop certain number of connections randomly so that your network will not face the problem of overfitting. Is that clear, guys? All of these discussions? Any questions, anyone? To understand what is a optimization technique, what is the role of optimization technique, and what is the role of dropout layer, and why we are using the dropout layer. Is that clear to all of you guys? Or any doubt? Let me also check it with YouTube, guys. Guys, my voice is clear to all of you? Okay, yeah. So I guess my voice is clear. So those who are facing issue with voice breaking kind of thing, so they can check their internet connection, right? Okay, there is one question, the full form for VAE. So VAE is, guys, VAE stands for Variational Auto Encoder. Okay, so VAE stands for Variational Auto Encoder, right? That's the VAE. Anyways, I guess my voice is clear, right? So Krishna, if you're facing any issue, probably you need to check your internet connection. Okay, guys. So this is one thing what I need to share with you guys. And then apart from that, guys, you can also select for each and every layer what will be your activation function. Like you can select, let's say sigmoid is a one kind of a activation function. Let's suppose you can select the sigmoid as the activation function for layer 1. You can select ReLU as the activation function for layer 2. You can select again ReLU as the activation function for layer 3. You can select another activation, some other activation function for output layer. So that means it's up to you which kind of a activation function you are using for each and every layer, right? This is one thing. Okay. So, okay, there is one like there is one term called as a perceptron. So guys, perceptron is nothing but it is the simplest neural network. It is one of the earliest and most simplest neural network. And what could be the most simplest neural network? Where you have one input layer, one hidden layer, and one output layer, right? So the most simplest network is called as a perceptron. Okay. Okay. So let me just give you an a snapshot how the things looks like. So let's suppose, guys, this is a one example where we have an input layer. So this is the input layer, and this is the output layer. So if you recall the yesterday's discussion, so there I mentioned that the first layer will always be the input layer. Last layer will always be the output layer. And then in between input and output, we have a hidden layer. So can you guys tell me how many hidden layers are there in this network? How many hidden layers are there in this network? Okay. Why four? Okay, so guys, there is only one hidden layer. That is this one. This is the hidden layer. And whatever these things you are seeing, these gray connections, this is nothing but the bias, right? So this is the bias we have for each and every node, except the input node. So this is a typical, very simple neural network. And you can see here, guys, what I was discussing with you. We initialize the neural network with some random value of the weights. So you can see here, this is some, let's say, some random values of the weight from which we have initialized this network. And let's say we have an input values like 0.05 and 0.10. So what this network will do, it will process these input data with the help of these weights. And how it will process? So for each and every node, we have two functionalities. One is the adder function, another one is the activation function. So depending upon what kind of an activation function you are using, accordingly, it will generate the output, and that output will be the input to the next layer nodes. Right? And in that way, it will generate the final output. And once we get the final output, the optimization technique will calculate the error. And based upon that error, it will try to minimize that. And how it will minimize? Just by tuning these values and trying to get the optimum value of these weights for each and every connection. Right? So in that way, this neural network works. Nikhil, I have like we have discussed this part. What is the bias? So it is nothing but just like a constant value, right? Please show the diagram. Sumona, which diagram? Internal bias. Internal bias means what? Are you asking for this diagram? So if you see here, guys, we are getting the connections from the previous nodes. And for each and every node, we have a bias available. Right? Bias is nothing but just a constant. Just like whatever we have a straight line equation, y is equals to mx plus c. So in that, we have this constant, right? This constant is there. So same like this equation, we have some bias. Okay. So that bias value, if you see here, this is what we have a bias value 0.35 for these two nodes, 0.60 for these two nodes. Right? So these are some random values. Exactly connections. So this is what we have exact connections, right? I mean, these two diagrams are exactly same. You can see here, we have a node, input node, and we have a next layer node, and then we have these connections. Along with that, we have a bias. Yes. Okay, guys. So with this, I hope you guys are clear how the things are arranged. Or let me do one thing. Let me also discuss with you guys how the processing is being done. I mean, how the values is being processed and we get the output. And from the output, how optimization technique will try to optimize this weights value. Let me also discuss that part with you guys so that you have a very clear-cut understanding, right? Okay, so before that, let me also discuss one more thing. So guys, this is what we understood. What is a neural network and what are the different layers and different terminologies, right? Now, when we are going to, design any kind of a neural network in in practical scenario, so there are a couple of steps you need to follow. Now, what are the steps? So broadly, there are three steps you need to follow to design any kind of a neural network. Step number one is, first of all, you need to define neural network architecture. Neural network architectures, right? First of all, you need to design the neural network architecture. Now, in this neural network architecture, what we design, so you need to specify how many number of hidden layers you are going to use. So you need to define the number of hidden layers. Then you need to define within each and every hidden layer how many number of nodes or neurons. So the number of nodes or neuron. And then you need to specify for each and every layer what will be your activation function. So activation function for each layer, right? Oh. So activation function for each layer. So this is what we design or define in the neural network architecture part. Now, once we define this neural network architecture part with these three information, then the second phase is called as a compilation. Compilation. In this phase, we will define what will be our loss function. So there are multiple loss functions are available. You can select any one of them. And what this loss function will do, it will calculate the error. So the error, whatever, error is being minimized by optimizer, that error is being calculated by some kind of a loss function. Okay. So there are different kind of a loss functions are available. So you need to define what kind of a loss functions you are using in your network. And then you need to select what will be your optimizer, right? So as I told you, gradient descent is one of the very basic optimizer. But apart from that, we have a number of optimizers available. If I name a couple of optimizers, so just like gradient descent, we have something called as a ADA grade is one kind of a optimizer. ADAM is another kind of a optimizer. RMS prop, another optimizer. Momentum is another kind of a optimizer. Or stochastic gradient descent, which in short we call it as a SGD, is another kind of a optimizer. So like that, we have a number of optimizers. So you need to select what will be your optimizer for this kind of a neural network. So this is the phase 2, compilation. And after that, the last phase is execution or training. The phase 3 is execution or model training. Right? Now, in case of a execution or model training, we train our or we execute our neural network. So whatever neural network you have defined here, so we start executing that neural network, or we start training this neural network over our input data. Now here, broadly we specify there is something called as, guys, a batch size. And then we have a one more parameter which we define. There is something called as a epoch. Right? There's something called as a batch size and epoch. So batch size is nothing but, let's suppose, guys, in your input data set, let's say this is my input data set, right? These are number of records what we have. And let's say there are, it starts from record number 1 to 100. Let's say I have 100 records. So with the help of batch size, you can define whether you want to apply this neural network or train the neural network over all the data, that means over all these 100 records at a time, or you want to train your neural network over some part of a data at each and every execution. So let's suppose if I define batch size equals to, let's say, 50. So what this neural network will do, it will first train or first execute over these 50 records, and then in the next iteration it will iterate over these 50 records, right? So it's up to you, in at a one time, how many records will be selected to train this model. Okay, is that clear, guys? What is the batch size? Yes or no? Okay, cool. And then, guys, we have something called as an epoch. So this epoch is nothing but, so this epoch is nothing but, guys, see, if my batch size is 50, so guys, how many iterations it will take to cover all the data? Can you guys tell me? How many iterations it will take to cover all these 100 records if my batch size is 50? Exactly, 2 iterations, right? Because in the first iteration, it will cover first 50 records. In the second iteration, it will cover next 50 records. In that way, it will cover all the 100 records in 2 iterations. So the epoch is nothing but how many number of iterations it will take to cover the complete data. So if I take epoch equals to 1, let me redefine what I told you. Let's say epoch equals to 1. That means it will cover all the 100 records only once. And to cover all the 100 records only once, it will take 2 iterations. Let's say my epoch value is 2. If the epoch is 2, that means this training or execution of neural network will cover these 100 records 2 times, right? It will execute over these 100 records 2 times. And to execute over this 100 record 2 times, it will take 4 iterations. Because to cover 100 records once, it will take 2 iterations. And again, it will cover iteration 3 and iteration 4. Then it will cover these 100 records 2 times. Right? So this is the meaning of epoch. Is that clear, guys? The difference between batch size and epoch? Any confusion? Anyone? Great. Okay. So with this information, let me show you how you can, design a typical neural network architecture, right? So up to this point, guys, any doubt or any queries, anyone, to understand any of the concept or any terminology? Okay, great. So just give me a minute, guys, so that I'll be ready with quotes and all. Just give me a minute. Okay, guys. So yeah, I will explain again what is this loss function and epoch. Don't worry. There is one question. If we are not specify the batch size, is it iterates all the available records? Yes. So for each and every iteration, it will consider all the records to train the model, right? Let me share my screen, guys. First of all, let me just show you the data set. Okay. So guys, this is our data set, what we are going to use. And this is the bank related data set. We have a different customers, the customer ID. We have a credit score for all of these customers. We have a gender, whether the customer was female or male, age of the customer, tenure, like in past, how many years the customer is associated with the bank, some balance amount, how many product or services the customer is using for this particular bank, whether the customer is having the credit card or not. So one signifies the customer is having the credit card. Zero means customer is not having the credit card. So in that way, we have a encoded information. Same like we have a something called is active member, whether the customer is currently an active member of the with the bank or not. So like one is the customer is an active member. Zero means customer is not using the facility of bank right now. And then some estimated salary of the customer. And in the last case, we have a variable called existed or not. So this is something a variable of like this is something we are calling as a target variable for which we are going to build our neural network model. Now, what is this variable? This variable is having two values, either 0 or 1, where 1 signifies the customer has left the bank, right? This is something called as a churn. In like in financial language, we have something called as a churn. Churn means the customer left the bank, right? So this is something what we have. The one signifies this particular customer has churned from the bank or left the bank, right? So we have a 1 where customer has churned. 0 signifies the customer is not churned. So over this particular target variable, which is existed or not, so we are going to build a neural network architecture or neural network model, which will classify the customers whether the customer has churned or not. So this kind of a model where we are classifying the records in one of the category. Here the category is either 1 or 0. This kind of a model is called as the classification model. Classification model, right? So we are going to build a deep learning based classification model where the model will do the prediction whether the customer will churn or not based upon these input information. The model will predict whether the customer will churn or not. Right? Is that clear, guys, what we are going to do? Okay, great. So let me just walk you through this Python notebook. So guys, when it comes to the deep learning or AI based, modeling, so there are two most commonly used libraries are there. One is called as a TensorFlow. Another one is a Keras. So these two libraries are most commonly used libraries when it comes to the deep learning based or AI based modeling, right? So under these packages or library, we have a number of modules or functions available to perform different tasks. And let me tell you, the Keras is built on the top of TensorFlow only, right? So we have a TensorFlow. Let's call it as a TF. On the top of the TensorFlow, we have a something called as a Keras. So to utilize the functionality of these two libraries, first of all, you need to install these two libraries, right? And let me tell you, you can only install the TensorFlow, and from that you can access the functionality of Keras because Keras is built on the top of TensorFlow only. So from the TensorFlow, you can access the Keras, or you can install these two libraries separately, and you can separately access the Keras functionalities, right? But you can't use Keras without TensorFlow because it is built on the top of TensorFlow only. So first of all, you need to install the TensorFlow, right? So what I'm going to do, guys, since I have already installed TensorFlow, so you guys need to remove this hash sign and run this particular line of code so that TensorFlow will get installed, and it will take some time, right? It will take a couple of minutes. And then I'm just importing these required libraries. You can also check whatever TensorFlow version you are using it. Cool. So with that, let me proceed. So first of all, I have imported my CSV file, which is a churn modeling dataset, the same dataset what I have showed you in Excel file. Or sorry, that was a CSV file actually. So this is the dataset what we have, and our target variable is this one. This is my target variable for which we are going to build our model, right? So before start building our model, let's check whether there is any abnormality present or not, and if there is any, we need to remove that. So see here, guys, in this data set, we have a customer ID. Just ignore this one because this is a unique ID which is not required at all. So the important variables are from credit score up to the target variable, which is existed or not. And you can see here, guys, except the gender variable, all other values are in numerical form. right? But the gender column or gender variable is having the some string or text-based information. And if you guys recall from the NLP-based concept, so there we have discussed that you can't apply any kind of modeling or statistical analysis over the text data. So you need to convert the text information into some uh, uh like uh numerical values, right? So, but that was related to the text analytics, where all the data is the text data. In this case, guys, if you can see what you can do, either you can drop this variable, you can just drop this variable, or if you see, guys, just use some basic logic. This gender variable is having two values, either female or male. So what I can do, I can assign some kind of a coding, like 1 stands for female, 0 stands for male. And in that way, I can replace this, string values with these numerical values, just like these variables, right? So this is something we are calling as a encoding the variable. Encoding variable, where we, just replace these string values and we use some kind of a numerical representation values, just like 0, 1 or 0, 1, 2, something like that, based upon how many values this particular variable is having. So this is what we are doing. And we are doing one more thing. We have just segregated our target variable as a y variable and all other variable as a x variable, right? So this is what we have done. So you can see here, this is my x variable, where we have a values from this up to this. And this is my target variable. And then like we have done the encoding over the gender variable. So to perform the encoding under the sklearn module, sklearn package, we have something called pre-processing as a module. And under that, we have one of the method called label encoder. What this label encoder will do, it will automatically do the same task what we have just discussed. So now you can see here, guys, for this gender variable, after applying the label encoding, we have a values like 0 or 1. So in this case, 0 stands for female and 1 stands for male. So in that way, we have this encoding. This is one thing. Okay. Now, over this data set, guys, now we are going to build our neural network architecture, because all the information are in the numerical form, right? So there are a couple of steps you guys need to follow to build the neural network. So you need to remember all of these 3 steps what we have discussed, just like define the network architecture, then compilation phase, and then execution phase. But before that, whatever data you have, so what we do, guys, we split this data. Let's suppose we have a data frame like DF, just like this complete data set. So before start building our model, what we do, we split this complete data set into 2 data sets. One is called as a training data set. Another one is a testing data set, right? Generally, the splitting is being done as, let's say, 80:20 ratio, or it may be 70:30. That means most of the data we put over training data set, and rest 20% or 30% data we put over the testing data set. And what we do, over this training data set, we build our model, right? So model building is being done over this training data set. So over this 80% or 70% data set, we build our model. And once our model is ready, so you need to test it, right? How well your model is performing. So for testing purpose, we use this testing data set to validate the model. So this testing data set we use to validate our model. Right? Whether our model is performing well or not. So this is the another concept of what we use in terms of the model building phase. Is that clear, guys? How computer identify 0 female 1 male? So Aishman, answer to your question. Uh, First of all, computer is not identifying 0 female or 1 is male. This is first thing. This particular method level encoder will do the encoding for these values. So what are the values? Female and male. Now, alphabetically, whatever is the first category, it will assign that category as a value 0. Alphabetically, the second category will get assigned value 1. And if you have a third category, so just arrange that category into alphabetical order, and accordingly, it will assign value 0, 1, 2, 3, like that. Okay. So in that way, you are getting 0 for female, 1 for male. Because alphabetically, F comes before M. Right? Yeah. Okay. So guys, this concept is clear. This training and testing dataset concept. Cool. Okay. So here we are following the same steps. Under the sklearn package, we have something called model selection module. Under that, we have a method called as a train test split. So you can directly utilize this method to split your data set. And what is our data set? X and Y, right? And here you need to specify what will be your test data size. So test data is, guys, the testing data. And you have a training data. So if my test data size is 20%, 0.2 is nothing but the 20%. So automatically 80% data will be over my training data set, right? You can also take it like 25% or 30%, something like that. And accordingly, the rest of the data set will be on the training part. So in that way, we are getting the X train, X test, Y train, and Y test. So what we are now going to do, we will build our model over this train data. And you can see 8,000 records are there for the train data. For testing, we have a 2,000 records. And once we build model over this training data, we will test the model over this test data, right? So in total, we have a 10,000 records. So out of 10,000, 8,000 records over the training data, 2,000 records over the test data. Okay. This is one thing. Now, apart from that, guys, there is another very important step while, before building the any kind of a neural network. So guys, when we are dealing with the deep learning based models, just before building the model, start building the model, you need to normalize your data set. You need to normalize your data set. This normalization is also called as a standardization. And this is also called as a feature scaling. Right? So these are the different terms. So that means you need to do the feature scaling or standardization or normalization just before building any kind of a deep learning based model. Okay. So to perform this task, Same under the sklearn module library, we have a pre-processing as a module, and under that we have a standard scalar as a method. Just apply this standard scalar over the training and test data set. So what it will do, it will normalize your data set so that all of the variables will be on the same, you can say like in the same range, so that there won't be any bias present for any of the variable, right? So now you can see that this is the standardized or normalized values of my all the variables, right? Now, once you do this feature scaling, then we start building the model. So if you recall, the first phase was define the network architecture. So what we do in that case, we need to define the layers, the number of nodes or neurons in each and every layer, as well as the activation function, right? So how we start? So first of all, guys, under the TensorFlow, we have a keras. Under the keras, we have a models as a module. And under that, we have a method called sequential. And why sequential? So you can recall the discussion what we have done at the beginning of this session. Why we are calling this neural network architecture as a sequential neural network? The reason being, information is flowing in a sequential manner. So we have something called sequential method under the keras. So we are just importing this sequential method as a ANN. ANN is a variable which will store this sequential method, right? Now at this time, we only have an empty neural network, which will be a sequential kind of a neural network. Now over this empty neural network, now we are going to add each and every layer, right? So first of all, you need to add the input layer. So how to add the input layer? So we have saved this sequential as a ANN. Under that, we have a method called add. And within this method, you need to use another method, that keras.layers.dense. That means we are going to use the dense layer. And over this dense layer, how many number of nodes will be there? So for that, we have an argument called units. Units will indicate the number of nodes for this particular layer. That means we are going to define the input layer, where I'm specifying there will be 9 nodes or 9 neurons like this. So like neuron 1, neuron 2, 3 up to the 9. So there will be 9 nodes in input layer. And also I'm specifying what will be the activation function. So we have a number of activation functions. You need to specify for each and every layer what will be your activation function, right? Now, if you're not sure how many number of nodes will be there in the input layer, so the best way to start with is, you can take the number of nodes for the input layer exactly same as the number of variables in your data set. So if you check here, in the input data, we have a 9 variables. That's why I have taken the 9 nodes for the input layer. Okay. So this is the way how you can define your input layer. Now my input layer is ready. Now I'm going to define my hidden layers. So it's up to you how many number of hidden layers you want to add. In this case, I'm going to add 3 hidden layers. So after defining the input layer, the second one is I'm defining hidden layer 1, 2, and 3. How? The same ANN dot add keras.layer.dense layer. And in the first hidden layer, I'm defining 16 nodes with the activation function ReLU. In the second hidden layer, which will be again a dense layer, total number of nodes will be again 16, activation function ReLU. I'm adding another hidden layer, which will be a dense hidden layer. The number of nodes will be 8 with the activation function ReLU. Now here I am just taking, I've just taken some random, number of nodes. you can change these values. You can take it like 20, 30, 32, 64, like that, or 11, 8, 6, 5, and you can try it, different number of nodes, and you can check the output. And if you want to add a couple of more hidden layers, just follow this approach. So below that, you can add another layer, and you can decide what would be your activation function and number of nodes. So this is the way how we define the hidden layers. And then finally, you need to define your output layer. The process is same, method is same. ann.add keras.layers.dense. And in the output layer, okay. So if you guys see our data set, our target variable is whether the customer churned or not, right? That means either 0 or 1. So what this architecture will do, in my output layer, I'm just specifying only one neuron. And what the output I will get, either 0 or 1, right? I don't need any other output. I need only one value, either 0 or 1. That's why I'm specifying number of nodes will be only 1. And activation function will be sigmoid. In case of a classification problem, your activation for output node activation function will be sigmoid or softmax. So for classification related modeling, for output layer, the activation function either will be sigmoid or softmax, right? So these are the details how you can define the network architecture. Is that clear, guys? How we are, adding layers and layers? Input layer, the maximum number of neurons are equal to total number of variables in the data. Yes, Nikhil, it is the best practice to start. Okay. But if you want, you can take the number of nodes greater than the number of variables also. You can also take it here as 16 nodes, or let's say 20 nodes, 30 nodes, 64 nodes. You can also try with those numbers. Please tell me the number of neurons taken in hidden layer. What should be the criteria? So as such, guys, there is no criteria, to be very frank. You need to try with different numbers, and you need to analyze the result, right? So like just by looking the data set, you can't decide what will be the best number of nodes for each and every hidden layers. So this is something you need to try it. Okay. Or in the Keras, there is a one facility is available. There is one module called Keras Tuner. What it will do, based upon your input data, it can provide you an initial guess what will be the approximately optimum number of nodes will be there, and how many hidden layers will be required for that input data. So you can get some initial idea just by using the Keras tuner. Okay, so it is one of the module available under the Keras. Right? Any other questions, guys? Anyone? Up to this point? To understand how we define the neural network architecture. Okay, cool. So this is what we have done with the phase 1, which is the you need to define the neural network architecture. So if you see here, guys, what is our architecture? We have an input layer. We have an input layer, and in this input layer, we have a 9 neurons, right? Then we have a 3 hidden layers. Hidden layer 1, let's say H1, hidden layer 2, H2, and then hidden layer 3, H3. And then we have an output layer. Then we have a final output. right? In that way, this is our architecture, right? Okay. So let's go to the second phase, which is the compilation. So as I told you guys, in the compilation phase, we will define what will be my loss function and what will be the optimizer. So there are multiple loss functions are there, but in case of a classification modeling, generally we adopt binary cross entropy as the loss function. So this is one particular function. We have a binary cross entropy, and based upon this function, the model will calculate the error, right? It will calculate the loss or error. And that error is being minimized by an optimizer called Adam, right? So we are using Adam optimizer. Okay. And then you can also specify, like if you want to calculate the accuracy of your model, you can also specify metric as a accuracy. But this option of accuracy is available for a classification model, right? So this is the compilation phase. And now is the time to execute our model over the input data set. So you need to just fit your model, ann.fit, fit this model over the train data set, X train and Y train. And you need to specify what will be your batch size and number of epochs, right? So here I have taken the batch size equals to 100. Okay. So in total, in the train data set, I have 8,000 records. Out of 8,000, in one iteration, it will take only 100 records. So guys, how many iterations it will need to cover all the 8,000 records if in a one iteration only 100 records is being taken? So just divide this 8,000 by 100. It will be 80, right? So to complete one epoch, it will execute 80 times to cover all these 8,000 records. And this is something we will do for 200 times. That means epoch 1, epoch 2, epoch 3, and so on up to epoch 200. And for each and every epoch, it will execute 80 times. So this is what, we are building a neural network over this data, and this is how we are executing our model. And you can also see, I have already done the execution, guys, because it will take some time. So you can see here, guys, this is the epoch. Out of 200, this is the first epoch, second epoch, third epoch. And for each and every epoch, it is executing 80 times. And for each and every execution, it will show you total time is being taken, what will the loss at this particular iteration, or at this particular epoch, the loss and accuracy. So for each and every epoch, what is the loss and what is the accuracy? So see here, the accuracy is here is a 79%, 79%, 79%. Here we have a 80%, 81%, 82%, 83% accuracy. Like that, we have this particular thing is being done for 200 epochs. And finally, we are getting the accuracy as a 86.8%, which is a very good accuracy, right? Is this part is clear, guys? Anyone is having any doubt or any queries to understand any of these steps? Adam is the name defined by you. Answer to your question, Ayushman. Adam is one kind of a optimizer, right? There are different kind of a optimizer. So Adam is one optimizer. Another one, if I name it like, there is something called as a ADA grade. ADA grade. ADA grade is another optimizer. there is something called as a RMS prop is another optimizer. Momentum is another optimizer, right? So likewise, we have a number of optimizers. Adam is one of the optimizers. You can select any one of them. Okay. So you need to mention which optimizer you are selecting. Okay, great. So if you guys understood this training part, so guys, up to this point, we have trained our model over training data set, right? And what is our model? ANN. So we have taken the name as ANN. You can also check the summary of your model. So here you will get in the input node, you have a in the input layer, you have a 9 node. In the first hidden layer, you have a 16 nodes. Second hidden layer, 16 nodes. Third hidden layer, 8 nodes. In the output node, output layer, we have only 1 node. And how many weights are being adjusted? All of this information you can see here, right? So for input node, we have a 90 weights is being adjusted, and so on. So in total, 667 times the weight is being adjusted. And then guys, what you can do, you can use this kind of a model for a prediction purpose. Okay. So what I'm going to do, this ANN model, whatever we have built, we are going to, do the prediction over the trained data set only. You can also perform the prediction over the test data, right? So whatever prediction I'm getting, I'm just saving this prediction into a variable called ypred train, and this is the prediction what I'm getting, right? And you can classify, this prediction either as 0 or 1. So if the value is greater than 0.5, just classify it as a 1, else 0. So in that way, we are getting these values. And you can check what is the accuracy at the training time. So it's a 72.9%. Okay. You can also do the same thing over the test data set. You can do the prediction over the test data. That means here we are validating our model. Over the text data, we are validating our model. And over the text data, the accuracy is a 70.7%. Right? So this is how we are building our neural network model, which will classify whether the customer is whether the customer will churn or not. Let me also show you how we utilize this model. So up to this point, you saw we are just applying this model over the train or test data set. Let's suppose, guys, we will hand over this model to the bank, and bank want to utilize this model for new customers, whether that particular customer will churn or not. Right? That is something we call it as a prediction. So let's suppose, guys, in the bank is getting one new customer with these information. The credit score for the new customer is this one. The customer is a male, age is 40 years old, the tenure is 3 years, balance is something like that. So all of the input information we have for that customer, and based upon this information, the bank want to know whether this customer will churn or not. So what bank will do? Bank will apply this model over this input information. So see here, guys, we are just applying this model for a prediction purpose over this input information. And then obviously you need to apply the normalization, because our model understand the normalized data. And then you can see here, whatever prediction I'm getting, if the value is greater than 0.5, make it as a 1, else 0. So 1 means it's a true. 1 means true, the customer will churn. 0 means false, the customer will not churn. So the output is false. That means this particular customer with this information will not churn. That means this customer will not leave the bank. So the bank can proceed with this particular customer. So this is how the client will utilize the models. right? I hope now these things will be very much clear, guys. What is ANN? So, guys, this model is the ANN model, right? Artificial neural network model, where we do classification and regression based modeling. This kind of a models are called as a ANN based model. What is ReLU means in activation function? Okay. So, okay, full form Vivo. What full form you are asking? Let me show you this thing. Just a minute. Okay, so let me show you this slide. So, you guys, this is the ReLU, which is one kind of a activation function, and this is the formula it is being utilized. Okay, and the full form for the ReLU is a rectified linear unit. Rectified linear unit. Okay, this is the ReLU, which is one kind of a activation function. Let me check what are the questions. Yes, Ayushman, you are correct. The financial, like in the financial business, this kind of a technique is being utilized. This attendance link is there in the chat box. You can fill this form, attendance form. Any other doubt, guys? With these things, guys, these things are very much important when when we are going to discuss some advanced concepts of generative AI, right? Just like RNN or sequence to sequence model or LSTM part. So these things will be very much required. Okay, there is one question. Any specific reason to use ReLU? So answer to your question, it has been found that out of all the activation functions, most of the times ReLU performs better than other activation functions for hidden layers. I'm talking about hidden layers, guys, not for output layer. For hidden layers, it has been found that most commonly used activation function is ReLU, which will give you, more optimum results compared to the other activation function. That's why if you see any of the neural network architecture example, there will be high chances that the architecture will be utilizing the ReLU as an activation function. Okay, I will come to this part, epoch and batches. I hope you got your, you got the answer, right? Basavraj. Okay, from Nikhil, there is one question. If only 80 epochs are required to complete 8,000, then Nikhil, not 80 epoch. Okay, let me just clear this point. Epoch and batch size. Okay. Guys, please pay attention here to understand what is the batch size and what is the epochs. See here, guys. We are going to train our model over training data set, and in the training data set, we have a 8,000 records. Right? That means we are going to apply our model over these 8,000 records. Now, here we are specifying, okay, let me just do it like this. Let me, okay. So these are the 8,000 records. Record 1, 2, 3, 4, and up to record 8,000. Right? And we are specifying batch size is equals to 100. So what does this mean of batch size is equals to 100? That means the model will get executed over 100 records at a time. That means in one iteration, it will only take the 100 records. In the second iteration, it will take next 100 records. That means it will be like in the iteration 1, it will only take the first 100 records. So these first 100 records will be taken for iteration 1. In the second iteration, it will take next 100 records. That's the iteration 2. And likewise, it will do up to the last data point. Right? So now tell me, guys, to cover 8,000 records, and when in one iteration, it only takes 100 records, how many total number of iterations are required? So just divide this 8,000 by 100. How much you will get? 80, right? So that means 80 iterations are needed to cover these 800 records once. Right? And this is we call as a epoch 1. So when the epoch is 1, that means it will execute 80 times to cover these 8,000 records. And if I say epoch equals to 2, that means this model needs to cover this 8,000 records 2 times. So to cover this 8,000 records once, it will take 80 iterations. To cover 2 times, it will take 80 into 2 iterations. And what we are saying, cover these 8,000 records 200 times. Right? Is that clear, guys? So you can also see here in the output part, total it will execute for 200 epochs, and this is the epoch 1. So for first epoch, it will execute it 80 times. Right? Then it will start the second epoch. Again, it will execute 80 times. In the third epoch, again, it will execute 80 times. So these things it will do for 200 times. So in the last, you can see it will do 200 times, and each and every time it will execute 80 times. Let me just run this one so that you can see the live. Just a minute, guys. I'm going to run this particular line again so that you can see. See here, guys. So for each and every epoch, it is being executed 80 times. Right? Great. Yes, this is a CSV file. Okay, guys, attendance link is there in the chat box. Attendance link is there, guys. Please see the chat box. Okay, so this is what I need to, discuss with you guys. Any other queries, guys? Anyone? There is one question. I'm thinking to learn robotics with AI to apply in real life applications. Is that good, or should I focus first on it? Okay, Aishman. So I will suggest you first focus on machine learning part before coming to this AI or deep learning. So if you're not, if you have not done this machine learning, course or that exercise, so please do that part. Then come to this deep learning or AI part. And then once you have done with the AI, then go for, if you're interested, then go for a robotics based application. This is the complete roadmap. Okay. Yeah, welcome. Do we need to write all programs from the scratch? It will be great if you write all the programs from the scratch so that you can, learn parallelly. Guys, attendance link is there in the chat box. Please check the chat box. Okay, don't worry. Amar will share again the attendance link. Don't worry, guys. There is another question. There are many functions in a module. How to cover all? So Ayushman, no need to when you are at a learning phase, no need to recall or no need to try mug up all of these functions, because when you start learning with any of the new topic, just try to get understanding of the things which are very much critical and important. Then gradually when you are comfortable with the topic or with the domain, you will automatically get understand like what are other things are required, right? So no need to try to cover all of these things uh, at once. Tanishka, I will suggest you like first focus on the basics of the Python programming and statistics part if you are a very much fresher guys. Okay. Yeah. Python with statistics with machine learning part. Okay, guys. So this is what I have for today's session. Tomorrow we will see some advanced concepts of this deep learning or AI with respect to the generative AI application. So over to Amar. So if you guys have any questions for Amar related to LMS portal or material, uh, he will resolve your queries.
Yeah, sure. Thank you. Guys, any question? Sumona, if you dropped an email, I hope you received an like reply on the same. Can you please confirm? Sir, my sister name is Satya Swarupa. She got an email verification error. How can we resolve this problem? So now we are do one thing. Forget the password once. That will work. Forget the password and then do a sign in again. So Mona, I'm asking you, you drop an email, you received and response on the same. Just let me know, yes or no. Okay, when you dropped an email, yesterday, can you please check the Sumona? Actually, our team is already replied. I'm able to check your status, and 5 hours ago we replied on the same. Please check your email properly. Thank you. Navya, no problem. Just ask your sister to go to this login page, forget the password, and then you can do a sign in again. Okay. Attendance link is not there in the chat box, sir. Mansa, I think if I'm not wrong, I shared for more than 5 to 10 times. I'm sharing it once again. No problem. Guys, in another question? Sumana, no problem. You can check it now as well. Check, I sent you the screenshot. Sir, how we will get the certificate from XLab through the email? Yes, Navya. After completion of this program, if your attendance is more than 60%, we'll share your certificate via registered email ID within 7 to 8 working days. Okay. You're welcome, guys. Yes, Preeti. What's your question? Nice session. Thank you so much. Naneshwari, I shared the attendance with. I'm sharing once again with you. Please check if you're able to receive that. 1 minute. I'm sharing that once again. You to participant, any query you have? You're enjoying the session? Yes, good. Thank you so much for response. Oh yeah, I shared the feedback form once again. Please mark your attendance. Don't forget. Great session. Okay. Lokesh, when you check material is not uploaded, you checked in the elements. When Lokesh? You are welcome, guys. Thank you so much for such a wonderful words. Lokesh, it's already uploaded. I checked that. You can check properly it once. So there is one question: when will be the surprise test? So my dear participant, if I am going to reveal now, what is the use of the surprise? It is surprise test, na? So suddenly we'll say you, okay, it's test time. So you can be prepared. I joined the course today. Can I able to get the certificate? Today the day 5. Yeah, probably maybe. 10 sessions you are going to do and you are going to mark your attendance more than 60%. If you are going to get the good marks in the our surprise test, definitely you will. Guys, any another question? Yes, good night. If you don't have any query or question, thank you so much. You can leave the session and we'll meet you on tomorrow at same time. I think there is no more question. So thank you so much for joining the session.